Well, everyone, I want to start welcoming you to the session. This is Regulatory Modeling and SIP Applications, being chaired by myself, Vizuete, and my colleague, Dr. Naresh Kumar. We're going to let people come in for at least a minute or two. We had another session that was ending, so just give us a minute or two, and thanks for coming. Hello, for the new folks who've just joined us. This is the Regulatory Modeling and SIP Application session. It's going to be happening from now until the 3 o'clock hour. Chaired by myself, Vizuete, and Naresh Kumar. If you're new, thanks for joining us. If you've been here, we're just going to wait just one more minute, and then we're going to go ahead and get started. We're going to do a little introductions and lay out kind of how we're going to lay out the session. If you have questions now that you have from already watching the presentations, there's a Q&A button near the bottom of your Zoom screen. If you would put the questions into that box, we'll be sure to get to them when we're talking about whatever presentation that it's referring to. And if we do run out of time, what's nice about having it in that box is that we'll make sure that all the questions will be answered eventually if we do run out of time. Thanks for coming, and just hang tight for just a second. All right, let's go ahead and get started. We can just start doing with little introductions, a little bit about the how we're going to set up the session today, and then we'll get started with our first set of speakers, and then our last set of speakers. So let me just do an introduction of myself, and then I'll let Dr. Kumar introduce himself, and he can lay out how we're going to lay out the session, and then we'll come back to me with the first summary of the talk, which is going to be from Andre Paradise with what's showing on the screen right now. Like I said before, if you're new here, if you have questions at any time, please enter them into the Q&A. There'll be it's a little button near the bottom of your Zoom screen rather. If you do that, we'll be sure, even if we run out of time, that we'll get an answer to your questions by one of the panelists. So please do that, and it helps us keep track of all the questions as well. We'll have opportunities for each presentation to have questions as well, and we'll give an opportunity, if you like, to unmute your mic and ask a question as well. We're going to have sufficient time within the hour. We're going to try a much equal time among all the presentations among the hour. So let me introduce myself. I'm one of the co-chairs that's been asked to do this. My name is William Vizuete. I'm on the faculty here on Environmental Science and Engineering at UNC Chapel Hill in the Gilling School of Public Health. My area of focus is atmospheric chemistry, the formation of aerosols, and it's also its connection with public health. And so with that, I'm going to pass it over to Naresh to go ahead and introduce himself.
Well, thank you, Will, and welcome everyone to the session. So we're going to get started soon. I'm Naresh Kumar. I'm the Executive Director of the Division of Atmospheric Sciences at Desert Research Institute in Reno, Nevada. Some of you may know me from my previous job. I moved here about it's been almost like 7 or 8 months. So it's been pretty interesting session so far. So this session is, as Will said, when we talk about SIP applications and regulatory modeling. We have 6 speakers total. We're going to divide them into 3 each. Will is going to introduce the first 3, and the way we are going to conduct this session, we as co-chairs will summarize the presentation a little bit, and then we'll ask the speakers to add anything else that they may want to add. Then we have some submitted questions that we'll go through. And then if there are any live questions, I think we'll go through those also at the same time. We don't have too many speakers, so hopefully we'll have enough time. If we get done early before the hour, we can have another open discussion if we need. So with that, Will, I think you can get started maybe with the first 3 talks.
Great, thank you, Naresh. Yeah, and so these are the folks, the talks that we grouped that we felt that primarily focused on policy implications or policy applications, and specifically the use of models to evaluate policies. The first one that we're going to talk about is the one here, is the economic valuation of the health benefits of decreasing the fine PM national or NAC standard in California. This uses the CMAC model, regional scale air quality model, to assess 2 standards for air quality. A more lenient one of 10 micrograms per cubic meter annually and 30 micrograms per cubic meter daily, and a more stringent one of 8 micrograms per cubic meter annually and 25 micrograms per cubic meter daily. And so the main findings, because hopefully, so we should have mentioned that all of these have been available, and hopefully you've had time to kind of look through these. So this is really just a reminder of kind of what hopefully you've already seen, and it is in no way supposed to be a replacement of what these talks really are. And so with that in mind, we're just going to go and say what the big findings were from this particular talk. So the implementation of the lenient standard leads to doubling of avoided premature mortality, and that was tripled when it went to the more stringent standard. There's show 25% reduced avoidance when they projected to the future for 2035, primarily due to regulatory efforts. And this was despite the increase in population growth, which had a negative effect on that. So the regulatory was primary efforts were to be credited for that future reduction. There's long-term mortality was 80% of the monetized health benefits, and both the lenient as well as the stringent plan led to significant savings due to health costs as measured. Health savings occur with high frequency in environmentally and socially disadvantaged communities. I thought that was a really interesting aspect of this talk that they were able to show very nicely with some data. And so the findings support in all that the independent particulate matter review panel for stricter standards yields significant social and economic benefits. And so with that, I'm going to now pass it over to the person who actually did the presentation to see if they want to add anything or any other context to that. And then we'll open it up for questions at that point. Go ahead, Andre.
Hi, that was a great summary. Probably the one thing I'd also like to mention is we actually found in our study that the significant monetary health benefits range from $50 billion to $180 billion dollars per year when the air quality standard is adjusted to either of the proposed versions considered.
Wonderful. There was a question on the Q&A. It's for Andre. Which emission sectors are most likely to be targeted for reductions if these lower standards are adopted?
Yeah, so the 2 main areas in California that we look at are kind of the San Joaquin air coastal basin and the South Coast air quality basin.
Great. All right. So if there are any questions for Andre about his talk, we'll take them both in the Q&A, or if you like to unmute, you can do that now. You have a question from the Q&A. Tesh Rao asks, what about the NH3 sectors?
For NH3 sectors, we didn't look as much into that, in this study.
Okay, great. All right, and then I actually had a few questions too. Well, here's another one. Oh, I meant the emission sectors,
Oh,
not the geographic areas, Andre.
yeah.
Oh, for UMA. Okay, sorry about that. I missed that as well.
Yeah, we primarily just looked at fine particulate matter in this study, not as much, I think, NH3 ammonia.
Okay, but I think Uma was originally asking which were most likely to be targeted for reductions. And I think she meant emission sectors, not or I may have been confused there. I don't know, Uma, am I misconstruing your question? If you, I don't know if you can unmute yourself. That's possible. All right, maybe not. Okay. All right. Yeah, so I wanted to know, so you mentioned something about the random forest model that you used in your model. Can you explain a little more what that is and how that was used and why was that chosen to be used for your California modeling?
Yeah. So this part of the data, which was considered part of the observation for 2018, was actually provided by a cooperator, Dr. Deng from Sinjua University. I'm not extremely familiar with the random forest model. I know generally the algorithm is an ensemble learning method, primarily based on decision trees, which has the advantage of accounting for both continuous and categorical input, and it's quite robust to outliers. Another thing it does is it provides variable importance rankings as well as out-of-bag errors for variable selection and model evaluation. In Dr. Ding's study, I know he built 2 random forest models, one with satellite AOD inputs from the MODIS project, and the other was from the AQS ground observation interpretation. In his study, he merged both predictions to obtain full spatial and temporal coverage of fine particulate matter. And this was primarily done since AOD has missingness in certain times and places.
Great, great. And just as a follow-up, since wildfires were so important in 2018, I think it was a record year or one of the record years. It's hard to keep track, but I think there were 7,500 wildfires, and that's your baseline year. And then in the future, there's a projection of no wildfires at all. So I'm just curious, I'm sure you thought about that. I mean, how appropriate of a baseline year is the one that you use, and why not try to project wildfires, at least in a sensitivity for the future, or have you thought about that?
No, yeah, that's a great point. I guess to answer the first part with respect to is an appropriate baseline for the 2018. And like, as you said, 2018, historical year for wildfires in California. I would probably say that it is still an appropriate baseline just because I think wildfires are becoming more frequent, and I think we'll see in the future that starts to be the new norm in California in the following years. Like just right now in 2020, we're looking, it's projected that the wildfire impact will even exceed what we experienced in 2018. To answer your second question, with regards to should we implement sensitivity for the 2035 just because wildfires weren't seen as much, that's a great suggestion. It's a bit difficult to predict wildfire scales in the future, but definitely in future studies, we will consider adding some related sensitivity. But for right now, this was just a preliminary investigation.
So if you were in some way could somehow add wildfires in the future, I mean, which direction do you think that would push your analysis toward, more benefits or less benefits?
Yeah, I think we'll definitely see an increase of benefits just because with higher wildfires, we get higher exposure to fine particulate matter. So I think what we observed in the 2035 case can definitely be seen as a conservative projection in benefits.
Okay. Oh, okay. I was just been told by the moderator that the attendees aren't allowed to unmute themselves. So I apologize for that. So we're all learning this as we go. So I apologize. So please then, if you do have a question, please put them in the Q&A. I'll have one last question, and then we'll let Andre go. We'll move on to the next talk. Everybody knows that performance of particulate matter in these regulatory models are poor at best for some times, especially for organic aerosols, right? Specifically. How does that model performance, have you guys taken that into account? Do you think that your conclusions are conservative because of that model performance, or what do you guys think about that? Or could you care a comment on that?
Yeah, so kind of with the simulation we did for 2018, we compared it to the AQS observation data. And from what we found, it seems to be a good enough model to justify our projection. The random forest model, the results we got was a correlation of 94%, and it only had a normalized mean bias of around 1.6% when compared to the AQS observation.
Excellent. All right. So with that, I'm gonna close this for Andre, and I'm gonna give folks one last. Oh, there's something in the Q&A. Oh, never mind. Thank you, Uma. Uma said I was able to answer a question. I appreciate that, Uma. Sorry for trying to get you unmuted there. All right. With Grad, looks like we're good with questions here. So we're going to go ahead and move on now to the second talk. And so let me get the title here. So Andre, thank you very much. I appreciate your help. That was a very interesting presentation. I'm glad I saw it, and it's still available, folks. So if you missed it, you want to know a little more detail about it, I suggest you get on the website and check it out. And Andre will be here till the remaining hour to answer any questions if you think of something later. So thank you, Andre. I appreciate your time.
Thank you.
Okay, so let's go ahead and move on now to our next presentation. This one's done, and I want to apologize in advance about the mispronunciation of your names. So I think it's Jeongran Yoon is how it's pronounced. And the title is Evaluation of 4 Different Methods to Calculate Relative Response Factors and Estimated Future Year Ozone Design Values. So the Relative Reduction Factor, or Response Factor rather, or RRF, is a prescribed non-attainment methodology to make use of models to predict a % reduction that can be applied to observational metrics to determine whether a region or area is an attainment or non-attainment of the NAAQS, right? And so the evaluation here is of that reduction metric, the metric that's used to decide how much reduction you can have on the design value to calculate your future design value. As it turns out, the metric or method used to calculate an RRF, it has various aspects to it. And so that was evaluated as part of this using actual modeling used in the New York region. And so to get to the findings, so since you have, as it turns out, for the calculation of an RRF at a monitor, you actually get a choice, or there's methods for which grid cell to pick and or average together to calculate what the model prediction is for the base, and then for the future, and then to calculate that % reduction to be applied to the design value, right? And so what it was found, when it's usually used, it's a 3x3 grid cell array where the monitor is centered that's used to calculate this. And inclusion of within that array of grid cells that are classified as water results in large biases in design values that are made from predicted values as opposed to observation-based design values. And specifically in the non-attainment areas, exclusion of water grid cells improves performance for the future design value as well. Now, this is specific, obviously, to this specific case, and so this may vary by region as well as by modeling year. And then the 2016 model results show for the same inputs that CMAQ has higher overpredictions in coastal areas, which I thought was very interesting when compared to CHEMEX. So that was actually one of the things I want to know a little more about. With that, I'm going to let our speaker or the person who did the presentation, you would like to add anything or provide some context, now's your opportunity, so please go ahead.
Thank you. Thank you for summarizing my presentation pretty well. And I think it covers pretty well. Thank you so much.
Well, so that's really nice. So, I'm always really nervous about this. Okay. That's great. So, so are there any questions from the audience so that they can put in the Q&A after reviewing the talk? or the findings here. I'll give people just a second here. Okay, well, I have some questions if that's okay. So we did have a question from one of the audience. Actually, this was one of the ones that were actually sent in prior to the session. And so we want to make sure that we collected everyone's questions. And so this first one was, did you have the opportunity to evaluate why CMAQ peak ozone predictions at the water site seem to be much higher than the peak ozone predicted in CHEMEX 7? I think that was my last bullet as well. So yeah, I'm really curious to hear about that as well.
Yes, compared to CHEMEX, CMAQ ozone predictions were significantly high at Groton site. We showed in the presentation. That site is located in water cell. And we looked into the issue and we found the treatment of a vertical diffusivity from both modeling systems can contribute to this difference. So we run another set of model, CMAQ model run using KZ-min set to know, and it decreased ozone predictions in that water cell dramatically, but not as much as CHEMEX, but it decreased the ozone predictions. And this could be one of the reasons. And one input we used and we think its difference is oceanic emissions. So for oceanic emissions for CHEMEX, it was processed by the CHEMEX tool, but for CMAQ, the oceanic emissions is built in the model. So that's that could be another reason to contribute the difference, but we haven't looked into detail yet.
Lose my cursor. All right, thank you for that. So you evaluated a key method in the EPA TEMA methodology, the RRF. And so based on the results that you have in this conclusion, would you make any recommended changes for either the national attainment methodology for the EPA, or perhaps something that in a weight of evidence argument, for example, that your region wants to put in to modify the RRF? So did your results make you think that there should be some changes in the policy?
Right now, no. We just started to look into these various methods, and right now our study is limited in scope. So we need a further study, and we would like to contribute to this discussion with the EPA.
Great. And then I think just the last one. So you did have a run where you switched out chemical mechanisms between carbon bond 5 and carbon bond 6. Some of the things that I know for the difference, it's, some of the olefin chemistry, for example, was upgraded in carbon bond 6. And so that should impact some of the ozone chemistry. Do you see a lot of differences between, as far as model performance when you switch mechanisms?
We switched it to from CV5 and CV6 mechanism, but we haven't checked the performance level detail. So I don't know how much like magnitude difference between those two mechanisms in the CHEMEX output.
Great. Let me check the Q&A here. Okay, it looks like we're okay there. So if any folks have any questions they want to ask, and I think now's a good time to do that. Otherwise, we're going to go ahead and move on to our third speaker. So just to give everyone an overview again, we're going to have 6 total speakers here that we're going to try to do this kind of summary, allow the speaker to talk a little bit. My session, or half session rather, is the 3 policy, closer to policy, and then Naresh is going to take the last 3. So this will be your last opportunity for any questions here. Can you please tell me how to say your first name, just so that I know? I just want to know, please.
Jungnan.
Jungan? Is that?
Jungnan.
Jungan? I'll try. Someday I'll get it.
Thank you.
All right, not seeing any questions. All right, well, thank you very much for your presentation and for your work. It's really interesting, and thank you for what you're doing for air quality up in New York. And so I appreciate that. Again, her presentation is available on the conference website. So if you want to check out or find any more details, please be there. And the speaker will be here till the end of the full hour. And so if you think of anything new, we can do that. All right, so let's move on to the third speaker of 6 today in our session. And this one is going to be done by a friend from the Hong Kong University of Science and Technology, Shugu Zhang, maybe, I hope. As the title is Improved Health Co-Benefits of Ozone and Nitrogen Oxides upon China's Integrated Air Quality Control Policies during 2015 to 2019. Again, this is an assessment of the effectiveness of policy decisions that are being made and the calculation of the co-benefits of those for both air quality and health. And so this was a series of modeling exercises that were done and to look at both reductions in nitrogen oxides and ozone. What was really interesting about this was that there were actually different regions that were being looked at that had different kind of emission sources and sectors. And there was really a differential in the impacts of where they occurred and how they occurred as a result of this policy. And I thought that was really nicely laid out. Some of the big findings were, so the model predicted integral health co-benefits for both ozone and NOx improvement, despite increasing ozone. So there was NOx inhibition that was occurring. And so when there was reduction of NOx in some of the heavily NOx areas, there was less ozone titration, so there was ozone increase. But the overall benefit was higher than the disbenefit that occurred as a result of that increase in ozone. The largest NO2 decreases were in the Hong Kong and then the Pearl River Delta Industrial Zone. The benefits were seen mainly from targeting emissions by power, traffic, and industry. There was also a scenario, this was interesting, where they had they electrified part of the transport fleet. I think they specifically focused on buses. However, there was a reduction there, but there was an increase in NOx due to power that had to be generated right around the region there, which was really a kind of, I guess, not too surprising, but the amount of magnitude of emissions, so it may suggest the age of these sources or the regulatory. Up to 2% avoidance of emergency hospital admissions due to these NOx and ozone reductions. So I'm going to go and pass it over to the speaker to allow them to add anything else or provide more context for us, please. Unless our speaker isn't on. I see you. No, I don't. Okay, so maybe our speaker isn't on. Yeah, I don't. Okay, so if there are any questions on that, I'm not sure. Well, if there are questions for this, I think what we'll do is please archive it in the chat or in the Q&A window, and we'll make sure that the speaker will get to that those questions for you. Naresh, you don't see the speaker on there.
Yeah, I don't see that. So
okay, all right.
I guess we can move on.
I think we should move on then. All right. So sorry about that, everyone. So I thought we had everybody at the beginning. So, all right, Naresh, we're going to go ahead and move on. I'm going to pass it over to my co-chair here. Thanks everyone for helping out in this session. Go ahead, Naresh. Let me get you to the slide you need.
Well, thank you, Will. Sarah just reminded us the previous speaker is from Hong Kong. It's 2:30 a.m. there, so not surprising.
Oh, there you go.
Yeah, so we're going to move on to our next set of 3 talks. The first one is looking at black carbon and nitrogen ratios at 2 air quality stations using computer modeling. The speaker is Sam Granger from University of Strathclyde. So if you go to the next slide, it talks, that gives a brief description of what he has done. The concept he's using is looking at NO2 to black carbon ratios at these monitoring sites to identify some sources of NO2. I think the concept is that usually the black carbon to NO2 ratio is quite small. And if you are near fresh sources of NO2, the ratio is further reduced. And then if you look at these pollution plots, polar plots for individual pollutants, as well as the ratio plots that can really help you identify some sources, because you can examine those different features of those ratios for analysis. So he's applied this technique at 2 of the monitoring stations that have a lot of data. The first one is called High Street Monitoring Station, and then they were able to identify, road junctions, car parking facility, even a brewery that earlier may not be known in emission sources as big sources of NO2. At the other monitoring station, also they were able to identify nearby roads and town had interchange as big sources of NO2. So I think the technique can be quite useful. So I'll ask Sam if he wants to add anything else.
Hello, yeah, thank you very much, Naresh. That's fantastic. Just want to add that the Well Park Brewery, the source there was black carbon rather than nitrogen dioxide, so it can work both ways. You can sort of have a hot spot, which is rich in NO2 relative to BC, and then you can have the BC, which is high to NO2. And using those sort of directions and the sort of shape of the features can be quite representative of the types of features found there. One of the main reason why we focused on ratios rather than looking at the single element point of view, which is more conventional, is because at these 2 monitoring stations, they're quite urban. So if you imagine a weather plot, it essentially shows just a bullseye where the monitoring station is. So low, calm wind conditions creating quite a lot of air pollution locally. But that might not be representative of the actual sources of air pollution within the city. So by using the ratios, we can actually find things which are slightly further away than the immediate sources.
Okay, well, thank you, Sam. So if there are any questions, please feel free to put those in Q&A. We do have some submitted questions on the next slide, so we can start with those first. So the first question, Sam, how would the approach work to identify sources that emit both NOx and black carbon, for example, diesel vehicles?
So essentially from vehicles, you have, I think it's sort of 10-to-1 ratio. So you have 1 part BC to 10 parts nitrogen dioxide coming out of these vehicles. We found both at a fracking site in Poland and within quite an urban street within the city of Glasgow. So it's really quite easy in that respect, as nitrogen dioxide seems to be giving off a lot more than BC, which is just a subspecies of particulate matter.
Okay. Then the second question is, can you explain the conditional probability function concept more? I think you used that in your presentation.
Yeah, so the conditional probability function is an interesting one. It evaluates whether something is true depending on other factors. So for example, that the level of nitrogen dioxide is above, let's say 20, given that the wind speed is, say, above 10. So it then uses all of these different factors, runs hundreds of different computations, and then plots them into little pixels, if you will, on the graphics. It's a really smart piece of kit.
Well, thank you, Sam. I don't see anything in Q&A, but please feel free to keep adding questions there, even for the previous speakers. I think we may have more time at the end, so we can definitely answer those questions as we go along. So thank you, Sam. We'll move on to the next presenter.
Thank you.
So our next presentation is on predicting ozone in the Colorado Front Range using EPA's air quality model. Our presenter is Rebecca Matichuk from EPA Region 8. So let me summarize her presentation first before we get her. So in the next slide, so what she has done is done modeling for the July and August 2014 period. There were 2 pretty intensive measurement campaigns during that time. So there's a Discover AQ and a Frappe period. So that provided a lot of data that could be used for model performance. And they have used two models at CMAC at 108 kilometers to provide the boundary conditions. And then they ran CMAC at 12 and 4 kilometers, two different resolutions for the Denver North Front Range domain. So because they had a lot of data, they were able to do detailed model performance. I'll just summarize here the key features. They're able to capture the temporal and the spatial variability of the observed pollutants overall, but found that the model is not able to capture the vertical distribution of ozone. As well as in terms of biases, the ozone was biased low, more for the 12 kilometer than for the 4 kilometer, but there was a lot of low bias for the species VOCs. Again, having that intensive periods helped them to be able to even do speciation model performance. And for NOx, they found a high positive bias. Overall, the performance was better at 4 kilometer resolution than at 12 kilometer. Then they also used the CMAC ISM feature to look at the source attribution. And what they found, I think, which has been known for a while in the Denver area, that the highest contribution came from outside sources, in this case, the boundary conditions. But then it was followed by other sources, the non-Colorado, biogenic sources, Colorado biogenics, and Colorado mobile sources. So again, not too much from anthropogenic sources within Colorado. So I'm going to ask Rebecca if she wants to add anything else.
Yeah, if you don't mind. I appreciate the summary. I think that covered the highlights and the overall results of our study, but did want to note some additional details just for folks in case they didn't have a lot of time to spend reviewing our presentation. A couple just little details for folks is that, we did use WRF to drive the meteorology in the platform. We also used version 2 of the 2014 National Emission Inventory. And then as noted here, we did use ISAM, and it was the latest release that Sergey covered at the beginning of our conference. So we were able to test that new tool out for the latest version of ISAM. I also too wanted to just spend a couple moments on acknowledging, the scientists, the groups, all the resources that were contributed to these field campaigns, Discover AQ and Frappe. As mentioned earlier, it did provide a very unique data set for a very comprehensive model performance evaluation. As we all know, that's usually something that we lack and always need more of in the modeling community, is the data sets to better understand the performance of our models. So I thought these field campaigns deserve the acknowledgement, and for others, this is a very extensive database to use. It included, for instance, it was very extremely helpful to have co-located measurements of multiple pollutants and meteorological parameters, to have the speciated VOCs. So also to point out the importance of this database, or the data sets from the field studies. If you just look at maybe the ozone model performance that we found in our study for the Colorado area, it may, folks may consider it to be typical to other studies, and it may not even indicate or clearly indicate any significant issues. But as you could see with what we were able to do with the data sets that were available, is when we started and had the ability to examine the ozone precursors and the meteorology more closely, we were starting to see issues with the model performance. So, and issues that we need to further examine. So before, we are comfortable with using this for regulatory decisions, we definitely have some additional work to do to make refinements to the platform, or to make any kind of improvements. So for some of our next steps, we did just take the model as is, just to see, how well our model could perform for ozone in the Colorado non-attainment area. But we do, and we are seeing some issues, particularly some of the, the results point to some issues with the emission inventory and maybe some of the components of the meteorological model. So for next steps, we do plan to try to look at making some refinements or improvements to emission inventory. There are studies out there that indicate issues with the oil and gas emissions, biogenic emissions, or even, BCPs. Also, we are looking towards trying to do some sensitivity studies to improve the meteorological model. In particular, ORD has developed, or there are some other options for running WAR, for instance, where we want to try to explore maybe using different vertical coordinate configuration options to see if we can help with some of the vertical distribution or transport issues that we did see in our evaluation. So, but with that, thanks for the overview of our presentation.
Well, thank you, Rebecca. So again, folks, if you have questions, please put those in Q&A. So we have a couple of questions that I already have. So first one is, you do show a lot of negative biases in VOC predictions. So do you have any speculation on what could be the reasons behind those?
Yeah, I mentioned it briefly before, is that we think that the largest or the biggest reason that may be contributing to the negative bias for the VOCs could be linked to the emission inventory. Recent studies have been coming out that indicate issues with the oil and gas source emissions, where the oil and gas emissions may be underestimated by at least a factor of 2. We've seen some studies come out, or some work being done on BCPs, and with those emissions possibly being underestimated by a factor of 2 or 3. ORD's also been working on some different approaches for the biogenic emissions database, and taking different approaches with the BELD or biogenic emission land use database. And that's, and we've actually tried some preliminary studies with ORD's new BELD database, and have seen some impacts that it has on the biogenic emissions for our area. So I think, the primary area is pointing towards the emission inventories and trying to make improvements there. Also, too, secondary contribution could be the meteorological model. So again, as I mentioned before, we'd like to take a look at different vertical coordinate configuration options to see if that could help us out to where the meteorological model may be impacting the transport of the emissions. Like I said, investigate that, and hopefully we can see some improvements.
So do you know if EPA is planning to update the emission estimates? You mentioned a few things. For example, oil and gas emissions are highly underestimated. Is there a plan to update those emissions?
I'd have to reach out to the actual emission folks with EPA. We're always reviewing the emissions. I know the group within EPA and OEQPS are always working with the community on making or understanding the emissions, QAing them, and ideally ultimately making improvements. So yes, I think as the agency, we're working on that. When those updates and how those updates would be transferred to the community, I'd have to reach out to others within the agency for that.
Okay, there's a live Q&A from Srinivas Rekha. Did you check the model performance of ozone for winter period at Denver?
No, this is just focusing on July and August of 2014. And as mentioned before, we focused on this because of the extensive database or data sets that we had available. So yeah, this is just focusing on summertime ozone.
Another question from the submitted ones, can controlling just the Colorado anthropogenic sources be sufficient to meet ozone NAAQS? I guess based on your source attribution, are you able to answer that question?
Yeah, so just briefly, I mean, we think that this area can attain the ozone NAAQS by controlling the anthropogenic emissions. However, I think that maybe more of the key issue here or question is determining how much of a reduction in these emissions are needed to attain the NAAQS. For this study, in order to try to address this issue or how much we may need to reduce the emissions, it will be important for us to improve the model performance, in particular, refining or having more accurate oil and gas emission inventories. So we need to work on the performance before I think we can get into how, but ideally, controlling these emissions would help with attaining the NAAQS. And then also, another objective of the study too is to just, use and test out ISAM. As Sergey mentioned earlier in the conference or this week, ISAM has gone through a lot of developments, and, ORD has put a lot of time and effort into improving that tool. So, and they're interested in having folks, utilize that tool so we can, make even more improvements if needed. So, our project here was to really try to test ISAM out, to become more comfortable with it, to help us understand the source contributions in this area, so that we can use it to inform, what kind of emission reductions would help this area to attain the NAAQS.
All right, well, thank you, Rebecca. So we'll move on to the last presentation. That's by Marcus Trail from Rambo Corporation. He's going to talk about investigating sources of ammonia uncertainty in modeling the Salt Lake City PM 2.5 non-attainment area. As you all know, Salt Lake City is pretty challenging to model because of persistent cold pools. So here's a summary of the presentation. So they did a lot of sensitivity simulations with CHEMEX modeling system to really understand what could be contributing to model under predictions of ammonia as well as ammonium nitrate during high PM 2.5 event in January of 2011. So when they did the base model performance, they did find that the model was under predicting ammonium nitrate, and that was the biggest contributor to PM 2.5. So that also had impact on the total PM 2.5 under prediction. So they did a lot of sensitivity simulations. I'm only including here the ones that actually were used in the final model performance, because the few of those sensitivities did not make big difference, and maybe Marcus can talk more about that also. But the ones that he did use in the final models configuration was lowering of the vertical mixing. I think many people have done that and shown that does improve the model performance in this area. They also doubled on-ride gasoline vehicle ammonia emissions. Again, that's has been shown in the literature that on-road gasoline vehicles emissions might be underestimated. And for the cold weather, they actually increase more, 40% more emissions from the on-road gasoline vehicles. They also increase the snow albedo to observed levels. So those were the four main sensitivity simulation that they did and adopted in the final configuration. So when they did that, they showed that overall model performance was much better and similar to model performance that we normally see when we run our regulatory models. So Marcus, do you want to add more to that summary?
Yeah, just a tiny bit. Thanks for that, Naresh. I think one thing I'd like to add is just kind of the impetus for the study. Obviously, the previous modeling, there were some ammonium nitrate under predictions. And previous to this project, the solution was to just add a big plug of ammonia emissions from an unknown source, kind of an unknown geography just across the modeling domain. So that was the impetus for the study. And we really wanted to dig into where if there was an ammonia emission shortfall, where was it coming from? And then what other, solutions besides just increasing ammonia could there be? Another thing I wanted to just mention is that as Naresh pointed out, some of these emissions increases that we ended up implementing, they were all supported by literature, and unfortunately, I don't have any of the references on hand right now, but there is a report, and I'd be happy to share with anyone if they're interested to see kind of we did a whole appendix, just kind of summarizing the literature supporting that. Yeah, I guess there's probably other things I could say, but may as well just save it for questions if there are any. And I probably wouldn't say anything that's not already in the presentation. So.
All right. Well, thank you, Marcus.
Sure.
So first question is, you did test bidirectional ammonia exchange, it seems, but did not use in the final simulation. I guess because it did not make a big difference. So why do you think it did not make significant difference in ammonia emissions when you applied bidirectional exchange?
Yeah, simply put, snow cover. So this was an episode in January. And within the bidirectional ammonia exchange subprogram, when there is snow present, it squelches any re-emission of ammonia. So that's why there was no change. Kind of to add to that is when we were doing this, we were kind of trying to look for literature that might expand on the actual if there are any bidirectional ammonia exchanges in the presence of snow. For example, if ammonia, one hypothesis was perhaps ammonia is trapped in the crystalline structure of the snow, and then when the snow melts, what happens to that ammonia? We didn't find any. We didn't come to any conclusion, but perhaps would be something interesting to ask later on.
Okay. Also, did you test the meteorological model's ability to predict persistent cold air pools?
So for this study, we used the MET modeling that the University of Utah had prepared for for UDAC SIP prior to this study. So we didn't do anything additional with the meteorology. They did do during that University of Utah did their model performance and found that it did predict the cold air pool during that time reasonably well. But that's kind of one of the conclusions we came to with this CHEMEX sensitivity study, is that perhaps there is something in the meteorology that's just not allowing, because there is still, so we did improve the performance, but there's still an underprediction of ammonium nitrate, and perhaps the meteorology is just not sufficiently holding things in place for long enough, or allowing the emissions to accumulate for long enough. So that's something else that is kind of an outstanding question.
Okay, and there's one live question from Heather Holmes. Do you know the major differences between how CAMEX recalculates or does not recalculate the MET variables from WRF compared to how MSIF recalculates some of these for CMAC? For example, the vertical eddy diffusivities.
No, I don't. I can follow up with you, Heather, afterwards, and look into it a little bit. I'm sure there are things, I just don't know them.
Okay, well, thank you. There's another question from Srinivas Rekha. How reasonable in simulation of particulate nitrate and ammonium aerosol during the cold months? I guess.
So is the question, how reasonably does the modeled ammonium nitrate compare to the measured?
Yeah, I'm trying to understand the questions. A little bit incomplete. Maybe how reasonable are the simulations of PM nitrate and ammonium aerosols?
So I'm trying to look maybe at some performance metrics. Just kind of a brief number: ammonium nitrate at Hawthorne, which is one of the major monitors here, that's downtown. roughly 20. So, sorry. So they're measuring roughly 35 micrograms per cubic meter on the highest day of ammonium nitrate. And the modeling is showing roughly 26 micrograms per cubic meter. I don't know if that answers your question, and that's just a quick number to throw out there.
And another question just came from server. Hono can form on snow, which can produce OH upon photolysis. Do you plan to consider snowbound Hono in the study?
We don't, only because the study is finished. However, if we do continue with further sensitivities, perhaps that's something we could include. Is there any, I guess you don't have to answer now, but I'd be interested to see any literature supporting that and kind of maybe how that would be implemented.
Yeah, I'm sure there is.
Yeah. Naresh, there's a couple questions in the chat, so let me.
Yep.
Yeah, so Rebecca, this one's for you. Do you have plans to look at PM 2.5 as well from your modeling? Oh, this is for Rebecca. Sorry, Magic.
Oh, sorry. Okay.
No problem. At this point, no. The focus of this current project is to focus on ozone. So, but we know that the model can be set up and has the capability of looking at PM 2.5, but that would sort of be further out. So yeah, our primary focus right now is just ozone.
And then a follow-up question was some of your, you said that some of your underperformance related to the VOC bias was associated with emissions from oil and gas. How confident you are they are oil and gas emissions, and what led you to arrive at that conclusion?
So that's just based on the work that's being done through NCAR right now and NOAA folks. So with some of our work groups or collaborations that we have with the other modeling community, at least there's initial and preliminary results that are showing some issues with the oil and gas emissions. So we're going to be basing it off of other work.
Sure. And then, so I've done a little bit of NACS work in Denver, and indicators seem to think it's VOC limited. Is your models, for at least for Denver County, or seem to be ozones formed under VOC limited conditions, or do you not know yet?
I would say I wouldn't want to point to one regime over the other at this point. Thanks.
Okay. All right, so we're coming here on the last 2 minutes of the session. I think that was all that was in the chat. I don't see any Q&A. So you have just the last few minutes you want to ask. I'm going to zoom through the chat to see if there was another one. Oh, here's one. This one's for Jean Gran. If I get that right. Based upon your work, do you have a recommendation for any tweaks to the current guidance from EPA's attainment demonstration? And would that change for ozone versus PM 2.5?
We haven't looked into PM 2.5 yet, so I don't have any opinion on PM 2.5. But we started to using various methods right now, and so we would like to continue to study this various method for that water cell. Where this particular method will be better than another. So yeah, they'll be depending on our further study.
Wonderful. All right, I'm not seeing any of the questions. Naresh, did you have anything else, questions you wanted to ask?
No, I think that is it. So I'll thank you all the speakers and all the attendees for great questions. We're right on time. So thank you, everyone. Thank you, Will.
All right, thank you, Naresh. And stick around. There's more great sessions to come for the rest of the week. I want to thank our volunteer, Jacob, for killing it with the questions. I want to thank Bram for helping us set this up. I want to thank Naresh for helping us do this. And of course, a big thank you to all the speakers who put together all these wonderful talks for us. they're still available. You can still go back and check them out. And I'm sure these speakers will be hanging around virtually for the rest of the week as well. So thank you, everyone. Take care. It was nice to see everyone. Thanks, Naresh. Thank you, panelists.
Bye.